Okay, we created one type of guitar synthesizer. Let's create another. This is going to be a frequency modulation type. Our previous one that's displayed here is kind of just, amplitude modulation. So let's get rid of a lot of stuff here. We're only going to need a couple of things. I'm going to get rid of all of that except for one, two, the amp scaler and the dry wet. And this is going to become frequency. If I can find the name. Where'd it go? And this is going to become depth, and we'll change those values in a little bit. All right, I'm also going to get rid of a lot of stuff over here, like those one poles. Don't need them. Then I'm going to do a little bit of other housekeeping here as well. I'm going to change this to a multiply by 0. I'm going to, for sure, get rid of that. And then I'm going to change that to FM out, FM out, and FM out. Okay, last thing, I'm going to get rid of those, and we're going to take this and realign it a bit so that it's easier to see all of this stuff coming in here. Okay, typically in frequency modulation, the signal that you're playing, you're using on the MIDI keyboard to create the first sine wave is the carrier. In this case, this is not going to be what we're doing. We're going to have our audio signal as the modulator. Interesting, I know. Instead, what I'm going to do is I'm going to create a K slider, and that K slider is going to be what we use to create our actual carrier wave. And that's just going to go to a cycle. Now, this K slider, we can have a range effectively of 0 to the Nyquist frequency, but that might be a little excessive for what we're really doing. So I'm going to connect a M to F to this. I'm going to use that M to F to actually control the frequency slider. And we can still control it manually if we want to get different things, or maybe type in microtonal intervals or anything like that. But I find this tends to work a little bit better. So that will be used to create the frequency. Next, what I'm going to do is I'm going to use the depth here. I'm going to modulate the audio signal by the depth. And then for both the frequency and the depth, I'm going to set their range up to the Nyquist frequency, 22050, because I'm set at 44.1 kilohertz. Amp is currently set to 1. Dry wet is going up to 1. The next thing that I'm going to do, and this is going to get a little bit interesting, is that I'm going to add a frequency. I'm going to create a plus tilde object, and the frequency that's coming out of our K slider, or our frequency slider, is going to get added to the audio signal that is being modulated by our depth. So this is going to create something with some huge values. It's going to create really harmonic or inharmonic tones. It will be super, super, super interesting. That is going to go to our cycle object, which will create a sine wave. Cycle is going to go directly to a multiply, 0 point, which will go to our amplitude slider. Just like that. And then from there, we're going to have a problem. And that problem is that that's going to connect up to this dry-wet balance, but cycle is always on. So as soon as I give it a value and it starts getting something input, it should keep playing and playing and playing. Why am I not actually hearing anything? This should be... There it is. Yeah, so it's not actually hooked up to work yet. What did I do wrong? I created that. Ah, I see. So what we need to do is we need to give it some other stuff. You can see that coming out of cycle, we've got this massive set of values, but I'll tell you what I did wrong. I didn't change the amplitude. And it still is going to keep going and going and going. But let that be a lesson. Make sure you always reset your values when you're playing with sliders from a previous patch. Okay, so how do I prevent that so that it's only going to go and have an amplitude when the modulator that's coming through from our input is playing? Well, let's do it with an envelope follower. So I'm going to create another multiply by 0 point, connect that up, and then I'm going to create a subpatch. And I can do that by using the letter P, which creates a subpatch. I'm going to call this end follower. And that creates a new patch that is going to pop up in Max. It's just a new patch, but I can't communicate with it just yet. I have to do a little bit of housekeeping work in order to make this accessible. Otherwise, right now, it's just a blank. You know, you take a look at it, there's no inputs, there's no outputs. So let's fix that. I'm going to create an inlet, which receives from outside of a patcher. And eventually that is going to go down here to an outlet. Now, this is important. These are created and they're given a name based on their position from left to right. So here's 1 to 1. If I duplicate the outlet, then it becomes 2. But if I move it over here, it becomes 1. So these are corresponding exactly to what you will see on the patch itself. So here's inlet 1, outlet 1, inlet 1, outlet 2. That's important. I'm actually going to duplicate this to have multiple inlets. So there's 3 of them. Now, what I'm going to do is I'm going to take audio in. And that audio, I only want values between 0 and 1. If I go into the negative territory, it's effectively just going to wrap around, and that's going to defeat the purpose of when it's silent, be silent. So what I'm going to do is create an absolute value, ABS, not ADS. Calculate the absolute value of a signal. I'm just going to connect that directly there. Now, you'll notice this looks like it's control. That's because it doesn't know what's coming in yet. It thinks that it could be either control data or audio data coming in. So that's pretty interesting. Next, what I'm going to do is I'm going to use slide. And slide is a really cool object that I really honestly don't use half as much as I should. Slide is going to connect from absolute value to the outlet. And if you take a look at the help file, slide is filtering a signal logarithmically. And it specifically is used for envelope following. If we take a look at this, you can see it ramp up and you can see it ramp down. It just creates that nice picture of the envelope that we're generating with SIG as it goes up and goes down here in the scope. Now, it takes 2 arguments, and those arguments are going to be the slide up and the slide down values. So this is going to be really important to know what type of values those take. Those are really going to be samples. And that's a problem because there's so many ways that this could go wrong. I could have it at 44.1, but then maybe accidentally change my sample rate to 48K, and what's going to happen? So I'll tell you what I'm going to do. I'm going to create the up and down value in samples. I'm going to do that by using ms2samps. This takes a value in milliseconds and converts it to samples. Output on the left is an audio signal. Output on the right is a control signal, just outputting the current sample rate. I'm going to connect it up like that. Then I'm going to connect this one up exactly the same way. So that will just automatically convert everything. Now, the last thing I'm going to do is I'm going to create a Patcherargs, which gives arguments to the patcher. So it generates initial values for a subpatch or for an abstraction. And I'm going to give it 110, and I'm going to give it a 100 point on both of those. Oh, I forgot the decimal point on the 10. And then I'm going to have it set to unpack FF because they're both floating point values. That goes there, and that goes there, and we are set. So Patcherargs will automatically load those values, and then I take a look. It's currently sent nothing and nothing. So what we're going to do is we're going to add some control values up on the top level of the patch, and that's going to be pretty easy to do. We can save the patch and reload, but I don't really want to do that, so I'm going to create 2 live.dials. And these live.dials are going to control what's going in to the envelope follower. And I'm going to give them both very, very, very similar values. I'm going to set this one to have unit style float, and it's going to have a range of 0 to 1 because this is going to be seconds. I could also set it to time seconds, which is kind of cool. So 0 to 1 milliseconds becomes, if I change it to 0 to 1,000, 0 to 1 second. I really kind of like that, so I'm just going to leave it like that. I'm going to duplicate it, and this is going to be my ramp down time. And then I'm going to give these guys load mess 10, because this is in milliseconds, and 100. Boom, boom. We have our envelope follower, but we need to connect it up. So we'll connect it there. And now it needs a copy of our signal. So we're going to connect it like so. Okay, at this point, if I play my signal, you should hear everything going through here. But you're only going to hear the signal of the FM Synth when Anton.aif is actually playing. So let's start it, and then I'm going to move the dry wet. Now, as a cool thing, don't forget that you can type in values on live.anything UI directly. So if you want this to go to exactly 55 Hertz, just type in 55 after you select that live.slider. And also, same with the live.dial, you can make it faster or slower. So frequency modulation, using the input signal as the modulator and the K slider as the carrier via envelope following to keep it all from playing only when it's receiving an audio signal. Kind of complicated, way too much fun.